We have only one inequality constraints, so we introduce only one slack variable. On the basis of one slack variable, we convert it into equality. Then our equation reduced in this form. Then we check the variables. So that means we have only one constraint. That means we need only one basic variable. So that basic variable may be in the form of the slack. We can use as x3, or you can consider as x1 or x2. No issue for that. So here we consider basic variable arbitrarily. Arbitrarily means the total number of variables are 3, x1, x2, x3. So we choose any one of them. So we choose x1 as a arbitrary variable to the basic variable. So we make two matrices. That means a matrix for basic variable and non-basic variable. So one variable we choose in the arbitrarily for basic. So that means x1 is the basic variable and x2, x3 is a non-basic variable. So we express the z. That means the objective function also reduced in the form of the non-basic variable. That means we replace the value of x1 in terms of x2, x3. So that means we convert the objective function in terms of x2, x3, and we differentiate with respect to non-basic variables. And when we differentiate it with respect to non-basic variables, so we see that the value, when we put the value, initial value x2, x3 equal to 0, so the derivative with respect to x2 gives us 10, and with respect to x3 gives us 4. So this increase in x2 will give the better improvement in the objective function, because x2 having del f upon del x2 having value 10 and this value having 4. So we determine how much we increase x2 should or may increase. So for calculating, that means the value of x2 for which del f upon del x2 vanishes, and the largest value of x2 can attain without deriving the basic variables. So then x2 will be the number of these two. So now we write as since x1. What is the value of x1? x1 we have 2 minus 2x2 minus x3. 2 minus 2x2 minus x3. And we put suppose x3 equal to 0. So we see that x1 becomes negative. X1 becomes negative. X1 becomes negative because that means when increase x2, because of if x2 is increased to a value greater than 1. Greater than 1. So when you increase the value of x2, so then x1 becomes a negative. So we determine the partial derivative. So the partial derivative del f upon del x2 vanishes at x2. So what is the value of x2? So del f upon del x2 is vanishes. So that means we calculate the value of x2. So we see that at what value del f upon del x2 is vanishes. So that means we write as x equal to 5 by 6. So you have to check these values for x3 equal to 0. So we consider x3 equal to 0. So at what value the partial derivative, that means del f upon del x2 is vanishes. So you this value you have to consider, that means 5 by 6 by obtaining the derivative del f upon del x2. So obtaining the derivative, then when put x2 equal to 0, sorry, x3 equal to 0, and del f upon del x3 is vanishes. So obtain the value of x2. So that this gives us 5 by 6. So now taking minimum of 1 and 5 by 6, 1 and 5 by 6. So we find that means x2 equal to 5 by 6. So the new basic variable is x2. So which is a minimum. So the new variable, basic variable is x2. So we initiate a new iteration by solving for x2 in terms of x1 and x3. So this calls us to give the minimum value. So we write the second iteration. So this is the next step, step number 4. So for next iteration, that means we put x2 as a basic variable. So when you put x2 as a basic variable, then you calculate the value of x1. Calculate the value of x2 in terms of x1 and x3. So what is the value of x2? So this is the equation we write as x1 plus x3 minus 2. This means that, yeah, 1 second. Our equations in this form. Equation is x1 plus 2x2 plus x3 equal to 2. So we find out the value of x2. So we write as 2 minus x1 minus x3. So we write the value of x2, 2 minus x1 minus x3, or you can write as 1 minus 1 by 2 x1 plus x3. So this is the value of x2, and now we make the basic variable. Basic variable is x2, work as x2, and a non-basic variable we write as x1, x3. So again we express z in terms of x1 and x3. So we see that z equal to fx1 x3. So we put the value of x2. So function is 4x1 plus 6x2. 4x1 plus 6x2. x2 means 1 by 2. 2 minus x1 minus x3. Minus 4x1 square. Minus 2x1 square. Minus 2x1 square minus 2 x1 x2. x2 means 1 by 2, 2 minus x1 minus x3, 2x1 x2 and minus 2x2 square minus 2x2 square. x2 square means 1 by 4 or 2 minus x1 minus x3 to the whole square. So we simplify this and find out the derivatives with respect to non-basic variable del f upon del x1. So directly you can differentiate this. Del f upon del x1 gives us 4 with respect to x1. With respect to x1, that means 2 3 is 6, so minus 3. 2 3 is 6 minus 3 and minus 4x1 minus 4x1 and this 2 cancel by 2 and this one minus 1 with respect to x1 and second function written as same minus first function differentiation of second function minus 1 and minus 1 by 2 and 2 differentiation of this 2 minus x1 minus x3 into differentiation with respect to x1 gives us minus 1. So this cancel by this. So we see that. So 4 minus 3 minus 4x1 or you put directly initial value, that means taking putting x1 equal to x3 equal to 0. Same things we do in iteration first. So you remember this. Here we also non-basic variable equal to 0. We put as x2 equal to x3 equal to 0. So same thing we do here. So we first we differentiate when we expressing the term and this function, and similarly we repeat this step again. So when you do same steps in each question twice or thrice, so you can understand easily. So that means we can write it that is x of n equal to 0, basic r 0. So the value of del f upon del x1 equal to 4 minus 3 means 1. When we put x equal to 0, so this gives us 0 and both are 0 gives us minus 2 here, minus 2, this one 0 and this minus minus plus to plus 2. So this gives us plus 2. So that means gives us value 1. Gives us the value 1. Similarly, you differentiate with respect to x3. That means second non-basic variable. So when you differentiate with respect to x3, you obtain with respect to x3. This one is 0. So 2 3 is 6. So that means minus 3. So first term this is minus 3 and this is 0. And here with respect to x3 gives us minus 1 to minus minus plus plus x1. And here with respect to x3 we differentiate. So 2 2 is 4, so 1 by 2. So we write as 1 by 2 into 2 and differentiation this 2 minus x1 minus x3 and the differentiation of x3 is minus 1. So this is the derivative with respect to x3 of f. So again take all non-basic variable equal to 0, that means x2 equal to x1 equal to x3 equal to 0. So we see that what is the value of del f upon del x3? The value of del f upon del x3 is equal to x1, this 0, so that means we write as minus 1. So here this is 0 and 2 1 is 2, so minus 1 and both are 0, minus minus plus, so plus ka 2. So this gives us minus 1. So one value, that means with respect to x1 is positive, that means 1, and x3 is negative. So this indicate, what indicate this? That x1 x1 can be introduced to increase x, that means z. Same we write here. So x2 improve or give the better improvement of the objective function because of x del f upon del x2 give the value 10, del f upon del x3 give the value 4. That means give maximum value. We consider the first derivative give the maximum value. On the basis of that we select this. Same case here we obtain two derivative, that means with respect to x1 and with respect to x3 we see that the value of x1 is positive, that means this is 1. So this value is 1 and this value is -1. So we select x1 on the basis of greater value. So now we write the next step, step 5. So if x1 is increased to a value greater than 2. So that means we see that when we increase the value of x1 greater than 2, so x2 becomes negative. Where we see these type of things, we see that here. That means we obtain the value of x2 here. So remember this is the value of x2. So in this we put x3 equal to 0. That means when we increase the value of x1 is 2. So that means when you put the value of x1 equal to 2. So 2 upon 2 is 1. So 1 minus 1 equal to 0. So 1 minus 1 equal to 0. Or when you increase the value of x1 here, you increase the value of x1 greater than 2. So that means x2 give the negative value. X2 give the negative value. So x2 will becomes negative. So since x2 equal to, we write as 1 minus 1 by 2 x1 plus x3, and we put x3 equal to 0. That means next जो basic variable है we put at 0. So the partial derivative becomes 0 at x equal to, that means here we check this value also. Here x1 equal to 1 by 3. So at what value the partial derivatives are 0? At what value the partial derivative are 0? So which partial derivative? This partial derivative. This partial derivative. How to check this partial derivative is 0? That means we simplify. So first when you put x3 equal to 0. So when you put x3 equal to 0, so what is the value of this? That means 4 minus 3 is 1. 1 minus 4x1. 1 minus 4x1, when you put x3 equal to 0, so gives us minus 2 plus x1. Minus 2 plus x1 and plus x1. Plus x1 and yes, we see that the x3 equal to 0. So this gives us minus minus plus. So plus 2 minus x1. So 2 cancel by 2, and how many x1s? X1 are 5 x1 minus and 2 plus. So we write as 1 minus 3x1. 1 minus 3x1. So 1 minus 3x1. So this is the value of del f upon del x. Understand, Minakshi? So this is the value of del f upon del x1. So when we put del f upon del x1, del f upon del x1 equal to 0, that means the first partial derivative vanishes is 0. So we write as 1 minus 3x1 equal to 0. So this gives us x1 equal to 1 by 3. Gives us x1 equal to 1 by 3. So this we use here. So we find two values. So you also remember this. That means here we also use 5 by 6. We also take this value. Where we take this value? We take this value from this derivative. So in this derivative, you put x3 equal to 0 and del f upon del x2 equal to 0. Find out the value of x2. So on the given function, that means which function? This one function. So the value of x1, this is given, and also same this function is given. You understand these basic things. So this function is given. So on the basis of that, we obtain two values. One value, uh, what is the maximum value? Maximum value, that means we make a order pair. So maximum value we write as when we put x3 equal to 0, x3 equal to 0. So our remaining equation in this form, 1 minus 1 by 2 into x1. So we, what value of x1 we put here? So we have to check directly. So when we put x1 equal to 2, so this means x2 gives us 0. So the maximum value you can put as x2 equal to 2. That means x1 equal to 2. So x2 gives us 0. So when you increase the value of x1, so 2, 2.5, 3, 4, 5, and so on, so x2 will be the negative. So when we increase the x1, x2 becomes negative. So we write this thing theoretically. X1 is increased to the value greater than 2. So when we increase the value of x1 greater than 2, so x2 will be negative. So maximum value we write as x2, x1 equal to 2. So you can make a order pair. So taking, we write as taking x the minimum of. So we just take minimum value of both. Taking minimum of what? Minimum of 2 or 1 by 3, because we have obtained two values. So 1 by 3 obtained from here and 2 obtained directly by putting x3 equal to 0. So that means gives us a positive value or 0, not negative. That means when we put greater than 2, so it gives us negative value. So we take the minimum of this order pair. So minimum, what is the minimum? We find the minimum value is 1 by 3. We find x1 equal to 1 by 3. So x1 equal to 1 by 3, this is the minimum. So this means that this is our new basic variable. So the new basic variable is x1. New basic variable is x1. So we determine del f upon del x3. We determine del x upon del x3. So when put x, you can see directly this one, del f upon del x3. That means gives us negative value -1. So gives us -1 at x2 equal to x3 equal to 0. So which is negative. So then this value is negative. You see that in previous step. So when this value is negative, so this means that, so we cannot take the negative variable in the basic. We cannot take the negative variable in the basic. So this means that x3 cannot become a basic variable. So we have only three variables total, x1, x2, and x3. We take two variables already in the basic. That means x1 and x2. x1 and x2. x3 cannot take in the basic variable, so that means our problem is solved. The optimal solution has been obtained. So what is the optimal solution? We write that the optimal solution as, so hence the optimal solution x1, we consider x1 is 1 by 3 and x2 we consider as 5 by 6. So we write the maximum z. Maximum z, we put the value of x1, x2 in z. So 4x1 plus 6x2 minus 2x1 square. 4x1 plus 6x2 minus x1 square, 2x1 square, minus 2x1 x2 minus 2x2 square. So you put the values, so this means 4 by 3 plus 5 by 6 when we put minus 2 by 9 minus 2 into 5, 6, 3 are 18 minus 2 into 5 by 25, 25 upon 36. So this is 4 upon 3, 2 9 are 18, 2 18 are 36. So we take 18 as LCM, so 3 6 plus 90, 4, 2 5 are 10, minus 25. So 5, that means minus 1, so 14, 15, 15 is 75, 75 upon 18, 6, 3, 25, 3 is 75, or 6, 3 is. So Z, maximum Z equal to this. So dear students, in quadratic programming problem, understand Mansi, Meenakshi, if you have any problem, then you can ask me. Shifali, Vibha. Okay, so we have two methods for solving quadratic programming problem. One method, Wolfe method, which is quite lengthy method because we use Kantakar condition. In Kantakar condition, we also apply the Lagrange form. But second method is simple when we compare with the first method. So basically, we use the iterations in second method. So we write all the steps here, so you understand all the steps. So this is our basic, that means objective function and a subjective constraints in quadratic programming problem. And we add a slack or surplus variable to make a inequality, and we make two forms, first as basic variable and non-basic variable. This is will be also arbitrarily. We have write here, we choose arbitrarily, no boundation or no restriction. You have to choose only slack variable as a basic variable. So this is your choice. You can take first variable as a basic, you can take third variable as a basic, you can take second variable as a basic. So basically we start with the first variable, which is x1, and first we take x1 as a basic, then solving After solving, we see that x2 in basic or x3 in basic. So we take x2 or x3 in basic. So that means this is quite different procedure. In simplex method, we may construct a table when we find incoming vector, outgoing vector, then make pivot, make into the basic and eliminate from the basic. The same procedure here, but this is different way. So we take in the basic or non-basic. So, or we check the value of derivatives. So that non-basic with respect to non-basic variable, we differentiate the function, and we see that which have the largest value. So on the basis of that, we take the basic variable, which is always in positive. So you see that third, when we solve this one, so then del f upon del x3 give the negative value. So on the basis of that, we directly write here the because x3 is the negative, which is negative value. So we cannot make a basic variable. So derivative play an important role. So on the basis of derivative, we say that we cannot make this as a basic variable. Just we stop here because two variable already we covered in basic. That means x1 and x2. x3 we cannot take, so we have only three variables total. So we write the answer, which values we have chosen for x1 and x3, x2. So this is x1 is 1 by 3 and x2 is 5 by 6. This one is 5 by 6. So you can also obtain easily x2, where we find x2. That means put del f upon del x2 equal to 0. This del f upon del x2 you put equal to 0 and x3 equal to 0, or solve this for x2. So you obtain the 5 by 6. Okay. What happened? Okay. Okay. So we take next topic.